Students, today we will start distance time graph. When we plot a distance with time, then it is called distance time graph. What are shapes of different graphs we will discuss in this class. So first of all, we'll check what is distance time graph. When distance covered by a body is plotted against a time, the graph obtained is called distance time graph. First case, when the body is in state of rest, then what will be the shape of distance time graph? Suppose car is in state of rest. It is not covering a distance. It is not moving. So what will be shape of distance time graph? Time is 0, 1, 2, 3, 4, 5, 6, so on. Time will not stop. Car is not covering a distance. From initial point, its distance is 10 meters in 0 second. When 1 second is passed, it is not traveling. Distance is same, 10 meters. In 2 seconds, distance is same, 10 meters. 3 seconds, 4 seconds, 5 seconds. Time is passing, but car is not covering a distance. So body is in state of rest. So what will be the shape of distance time graph? We have to discuss in this class. This is graph. This will be the shape of graph. But how this shape is obtained? We will take time on x-axis and distance on y-axis. Suppose distance is denoted by s, or you can write full distance. Time is 0, 1, 2, 3, 4, 5, 6, so on. Distance at 0 is 10, at 1 is also 10. So we will take distance 2, 4, 6, 8, 10, 12. You can take any scale, 5, 10, 15, 20, no issue. So in this case, at time t is 0, distance of the car from the initial point is 10. So we'll mark it as this point. At 1 second, distance is 10. In 2 seconds, distance is 10. Time is 3 seconds, but distance is 10. Time is 4 seconds, but distance is 10. Time is 5 seconds, distance is 10. Car is not moving. So when we join these points, we will get distance time graph when the body is in state of rest. So this is the shape of the graph when the body is in state of rest, and this is called distance time graph for a body when it is not covering a distance. Now second case, when the body is in state of rest, its distance time graph will attain this shape. This is the second case when the body moves with uniform speed. First was body was in state of rest. Now car is moving and road is clear. It is not changing its speed. So speed is uniform. It is traveling, but with uniform speed, there is no change in its speed. 0, 1 second, it has covered 10 meters. In 2 seconds, car has covered 20 meters. In 3 seconds, car has covered 30. In 4 seconds, car has covered 40 meters. But when you divide distance with speed, you will get the same answer. Since speed is distance divided by time. So 10 divided by 1, your answer will be 10 meters. 20 divided by 2, your answer is 10. 30 distance divided by time, your answer is 10. 40 divided by 3, your answer is 10 meter per second. This is the speed. Speed is uniform. Now you have to draw the speed time graph. This is the graph. We will take time and speed, time and distance. So distance time graph will be in this shape. How this shape is obtained? We will take time. We will take distance on y-axis. Time is 0, 1 second, 2 second, 3, 4, 5, 6. And distance traveled was 10, 20, 30, 40. 10. Distance traveled was in 0 second. It was 0. When 0, this is 10, 20, 30, 40, 50, so on. For 0 second, distance is 0. For 1 second, distance traveled is 10. So this is the point. For 2 second, distance traveled is 20. For 3 seconds, distance traveled is 30. For 4 seconds, distance traveled is 40. In 5th second, car has covered a distance of 50 meter. And in 6 seconds, car has traveled a distance of 60 meter. And so on. When we join these points, we will get distance and time graph. So these are the points. And this is the, when we join these points, this is called distance time graph. So for finding the distance time graph, first of all, you will plot the time along x-axis and distance along y-axis and join these points. The line which you obtain, that line is called distance time graph. This is the distance time graph for uniform motion of the body. Next, this was the distance time graph. Time. Along y-axis, you will take the distance. This is the distance time graph when a car is moving with uniform speed. But when a car is moving with uniform speed, but its speed is increasing, or speed is decreasing, then what will be the shape of distance time graph? This distance time graph is when a car is moving with uniform speed, and this is the distance time graph when car is increasing its speed. When you take at any instant, for example, this is the 10 and this is the 1 second. This is the point. This is 20 and time is 1 second. Distance is 0.5 seconds. So speed will be in first point. Suppose this is point A and this is point B. At point A, speed is 10 divided by 0.5. 20. In this point, at point B, distance traveled is about 20, and time is 1 second. 20 divided by 1, answer is your 20. Next is 30. Point C. This is 30. And time is approximately 1.5. 30 divided by 1.5, your answer will be also 20. So whenever there is straight line, then speed will be uniform. This is also straight line. So speed is uniform. So straight line shows that car is moving with uniform speed. When body is moving with uniform decreasing speed, if speed is decreasing, car is moving, it is slowing down its speed. Suppose time is 0, distance 50 meter. Time is 1 second, distance is 40, 2 second, distance is 30, 3 second, distance is for 20, and 4 second, distance traveled is 10 meter. Then distance time graph will be in this shape. This is the decreasing speed. Uniformly decreasing speed, then distance time graph will be in this shape. Suppose we take 2 points on this graph. This is point A and this is point B. This is the distance and this one is the distance. Suppose this is 0. This is 10 meter. This is 20 meter. And time is, this is 1 second. And this is 2 seconds. In first point, point A, speed was 20 divided by 1, that is 20 meter per second. Since speed is distance divided by time. This is the first point. And this is the second point. Now, distance is 10 divided by 2. Your answer will be 5. It means that speed is decreasing. First speed was 20. Now speed is 5 meter. When a body moves with decreasing speed, uniformly decreasing speed, then distance time graph will attain this shape. When body moves with non-uniform increasing speed, speed is increasing, but it is not uniform. Sometimes it is increasing 10 meter per second. Sometimes it is increasing 15 meter per second. Sometimes it is increasing 25 meter per second. Then what will be the shape of the distance time graph? This is the time 0, 1, 2, 3, 4. And speed, distance traveled in 1 second, 10 meter. In 2 seconds, 15. In 3 seconds, 25. In 4 seconds, 40. Distance traveled is not uniform. That means speed is increasing and it is not uniform. When body moves with non-uniform increasing speed, then distance time graph will be in this shape. In curve shape, but it is moving in upward direction. Gradient of distance time graph will give the speed of the body. Gradient, how you will get the gradient? Vertical distance over horizontal distance. That means you will take 2 points on y-axis and these are y1 and y2. You will subtract these 2 points. Similarly, take 2 points on x-axis, x2 minus x1. When you will divide these 2 points, you will get the gradient. And this gradient will give the speed of the body. This is a graph. This is the speed which is increasing. We will take time on this axis and distance covered on this axis. Time is 0, 1, 2, 3, 4, 5, 6, 7. Distance was 10, 20, 30, 40, 50, 60, 70, so on. It is in meters. Time is in seconds. You want to find what is the speed of the body. Graph is in this shape. You will draw the tangent on this curve. This is the tangent. You will take 2 points on this tangent. Suppose I have taken this point, and second point I have taken this. This is y1. This is y2. This is along y-axis. You will make a triangle. And this is your x1. And this is your x2. So formula for finding the gradient equal to y2 minus y1 over x2 minus x1. This will give the speed of the body. So speed of the body, y2 is 50 minus y1. y1 is 30. x2. This is x2, 6.5. Minus x1. This is x1. This is approximately 4.5. So 30, 50 minus 30, it will become 20. Divided by 2, that is 10 meter per second. So gradient of speed time graph gives the speed of the body. For finding the gradient, first of all, you have to draw the tangent on the graph. Then you will take 2 points on the tangent, and then you have to apply the formula for gradient, which is y2 minus y1 over x2 minus x1. This gives the speed of the body at any point on the graph. For non-uniform speed motion, when speed is decreasing, that was increasing, now speed is decreasing. When car is applying a brakes, distance time graph, this speed and time. For non-uniform, when speed is decreasing, then graph will be in this shape. In increasing speed, graph was in upwards direction. In decreasing, graph is in downward direction. So how you will find the speed when it is decreasing? Car is moving with non-uniform. So same process, you have to draw the gradient on the graph. And when a body is moving with uniform speed, then distance time graph will be in this shape. I will summarize all this. This is the time. And this is the distance. So first case was when a body is moving with uniform, then graph will be in this shape. When body is moving with uniform speed, when a body is in state of rest, when body is in state of rest, then graph will be in this shape. When a body is moving with uniform speed, then graph will be in this shape. When a body is moving with increasing speed, then shape of graph will be red. When a body is moving with decreasing speed, then this is the shape of the graph. Since this is curved, so you have to draw the tangent. After drawing the tangent, you will take the gradient on distance time graph. You will get the speed of the body. Examination style question. Underline the vector in the following quantities. In these quantities, which is vector, which require direction, density, it does not need any direction. Energy does not need. Force, it requires direction. Mass does not need. Velocity needs direction. Volume does not need. B part, a small metal bar is dropped into air with a velocity of 40 meters per second vertically upward. Graph shows the velocity changes with the time until the ball reach its maximum height. Velocity and time is given. Use the graph to find number one, the time at which ball reached its maximum height. What will be the maximum height when ball reach? This is the velocity. First velocity was 40. When it is moving in upward direction, its velocity is decreasing. Now, at this point, velocity is 0. And time is 4.1, 4.2 seconds. So time will be from the graph, it is 4.2 seconds. Deceleration of the ball. You have to find the deceleration. Deceleration is V2 minus V1 divided by time. Initial minus final. This is the initial and this is the final. Final is 0. Minus initial was 40 and time taken was 4.2. This will be equal to 9 point something meter per second square. And this answer is negative, so it is called deceleration. Next, figure shows the distance time graph for a moving object. Describe the speed of the object between points A and B. What is the A and B? This one. It is when you draw the tangent. Since it is down the tangent. When curve is down the tangent, then speed is decreasing. B and C, it is straight line, that is constant. State whether the acceleration of the object is 0, negative or positive. As shown between points A and B. A and B, when speed is decreasing, then acceleration is negative. B to C, there is no change in speed, then acceleration will be 0. Calculate the average speed of the object during 40 seconds. Total distance was 50. Total time is 40. Formula for finding the average speed. Total distance divided by total time. 50 divided by 40. 1.25 meter per second. This is the speed of the body, which is average speed. Thank you.